chapter number 20 and we'll start today from the problem number 37. Okay, so it says a student drops a pebble from the edge of a cliff vertical cliff the pebble hits the ground four seconds after it was dropped. What is the height of the cliff? What is the height of the cliff? Now, as you understand, this is the problem related to the motion under gravity. So, if I say this has been dropped from a cliff, that means ultimately it is drop from a height h say. Okay, now it has reached drop means, so it has freely dropped, so that means initial velocity has to be 0. That is not any force, only just dropped this way. So it will reach after some time, so that time is given, the travel time is given, t is equal to 4 seconds. So this is the information is given. So now as it motion under gravity, the equation that we have learned, ut plus half gt square. Okay, now as it is falling from top to bottom, so it is towards the gravitational pull, that means acceleration will be positive here. Second thing is that that h is the height of that, we have assumed. U, this case is 0. Now if I put the value u is equal to 0, t may be 4, I say, that is given. And one more thing, when g is nothing is mentioned, for the easy calculation, we can assume it a round figure of 10 meter per second. So otherwise the value is exactly 9.81, or for any other case 9.8 you can consider, or in case there is nothing is mentioned, for the sake of advantage you can take, but you have to mention that we have taken g value is 10 meter per second. That is also good, no issue. So there I will put the value of g 10 and t is again 4 square. So this first part will be 0, second part will be 4 square means 16, 160 upon 2. So ultimately the value will be 80. And what is the unit? Because acceleration is the only unit is given, otherwise that is the second. So this has to be in meter. Okay. So this equation I have explained in the last video, in number 36, that means the last problem of the last video. They have explained about this equation that is similar to the linear equation, but as it is motion under gravity, only acceleration will be constant here. During dropping it will be positive g, and during upward motion it will be negative. The only difference is that, otherwise the equation is just symmetrical to the linear equation. Okay, now moving to the problem 38. Okay, so it says a car moving with a constant acceleration covers the distance between 2 points between 180 meter apart 180 meter apart in 6 seconds. If its speed as it passes the second point as it passes the second point is 45 meter per second, then find the speed at first point. Okay, so this is your task. Now what is that? A car is moving with a constant acceleration, then we can assume that moving in a straight line covers a distance between 2 points. There may be 2 points A and B. The distance is 180 meter apart, and the distance traveled by in 6 seconds. If the speed as it passes to the second point, here the speed is here 45 meter per second. Now you have to find u. So u unknown, v you can assume it is v, final velocity, time is known, distance is known. So what we can use? We can use first thing is that first equation we use v is equal to u plus at, as it is with moving with an acceleration. So v is equal to ut. So v you know 45, u is equal to unknown plus a also unknown, acceleration, and time is known 6. So from there it is 6a plus u is equal to 45. This is one equation. Second equation, your distance is known. So if I put v square is equal to u square plus 2as, then v square is equal to or else it will be a much bigger calculation. Otherwise you can use s is equal to, this will give you a smaller calculation, half at square, s is equal to 180, u is equal to unknown, t is 6, so that will give you, that will turn it 6u plus half into a into t square means 6 square 36. So if I cancel it, it will be 18. So if I divide both all the terms by 6, it will become 30. It will become u, and this will become 3a. So it will be very easy to calculate this as a second equation. Now if I replace the value of u from here, so u is with 30 minus 3a, so 6a plus 30 minus 3a, instead of u I can put it here, will be 45. So 3a is equal to 15 or a is equal to 5. Now as you have got a, you can put it in any equation. So here we got 30 is equal to u plus 3 into a means 5. So u is equal to 15. So that is the requirement 15. The unit will be meter per second. So this is the requirement of the problem. Speed at first point. Okay. Moving to problem number 39. In problem number 39, it says a body starting, can it be seen? Yes. Starting with a velocity v, with a velocity v, returns to its initial position after t seconds. After t second, with the same speed, with the same speed along the same line, along the same line, what is its acceleration? Okay, so now the car is moving following a path. Let's say A and B are the destinations, starting point and end point. Velocity while going from A to B is v, and v returns to its initial position. That means initially he started from A to B, so he has moved from A to B, then after returns back B to A, so he has ultimately coming back to A. So the total travel time is t. Okay, now your initial velocity v, going back with the same velocity, so you can use v is equal to u plus at. So you have to find the acceleration. So this is the acceleration. Now final velocity is what? The magnitude is same, the same what is that? The same speed. So that means final, if I say the initial velocity v, final will be the minus v, because that is changing the direction. So initial velocity is v, and acceleration, if I assume a, and total time t. So from here we can say that at is equal to nothing but v will go side 2v. So a acceleration will be 2v by t unit. If it is not given anything, so you have to write unit. So this is the value for this when it is written in the same speed. Okay, moving to 40. Okay, 40. A ball dropped freely. A ball dropped freely takes 0.2 second to travel the last 6 meter distance before hitting the ground. Before hitting the ground, find total time of fall. Total time of fall. Okay, so G is given as 10 meter per second square. So if this is the case, a ball dropped from freely, so that means it is at height something. Okay, so this may be, we can assume it is ground as h. Freely means your u is equal to 0, takes 0.2 seconds. So the time taken is equal to 0.2 seconds to travel the last 6 meter. That means if let's say this is 6 meter, it is taking 0.2 second. Okay, before it is hitting the ground. So the information is this last 6 meter 0.2 and the total height I have assumed h. So let's say this is u total. So here he may achieve some velocity. I don't know whether it is useful or not. So for the first equation, if I take the total height, so the time for this, if I assume for this time, I say t. So the total height will be covered ut plus half gt square if I use the formula. So for this is the common formula h. So h will be capital H, u will be 0, so this term will be 0 plus half into g into t will be t plus 0.2. So this will be the first. So if I simplify, this is the g I am taking 10, so this will be 5 into t plus 0.2 means 1 by 5. Okay, this is the first equation. And if I consider the height up to this, then what would be the equation? If I take this equation, so in this case height will be h minus 6, second case h minus 6, or yes, h minus 6. If I take this height is equal to this case also, if I consider ut, the same formula, h minus 6, u will be 0, t will be t I have taken, and then ultimately it is half g into t square. So if I simplify, h minus 6 is equal to g I have taken 10, so it will be 5 t square. This will be second equation. Now from this 2, so I am just rubbing it out to get The equation already came 1 and 2. So if I replace h here, so it will become 5 t plus 1 by, oh, this has to be square, sorry, I forgot it. So it has to be square. So 1 by 5 whole square minus 6 is equal to 5 t square. Now expand it to t square plus 2 by 5 t plus 1 by 25 minus 6 is equal to 5 t square, or multiplied with 5. I am just removing the bracket. 5 t square plus 2t plus 1 by 5 minus 6 is equal to 5 t square. 5 2 1 by 5. Okay, this is cancelled out. So 2t is equal to 6 minus 1 by 5, that is 30. 6 minus 1 by 30, 29 by 5. So that will be, t will be, right, 2t is equal to 5, 1 by 5. This will be 5 into t square, 2 into 1 by 50 by 5 square, 1 by 5, 2 by 10 is equal to 1 by 5, 5 square, 1 by 5, okay, 0.2, okay, 6, a minus 6 is equal to, how it is, yes. So t, now rub this equation. So what is t here? T I am getting is equal to 29 by 10. So that means t is equal to 2.9 second. So what is the requirement? Find total time of fall. The total time is t plus, total time is t plus 0.2, that means 2.9 plus 0.2, that will give you 3.1 second. Okay. Okay. So this is for now. In the next video or next chapter, I will bring from 41 onwards. Thank you.